Hello, and welcome to the Joy of Coding. Today we're going to talk about functions, the true power of programming. So why are we talking about functions anyways? Why are they so important? Well, first, a function allows us to name a group of code statements, which makes our programs easier to read, test, and debug. Since the majority of development time can be spent debugging, any savings we can get there in terms of time are super important. So how does it help us do that? How does it help us simplify testing and debugging? Well, it allows us to focus our attention on one function at a time before we try and test and debug the whole program. This is kind of like how you might focus on cleaning one room of your home instead of all the rooms at the same time. Can you imagine someone trying to mop, broom, and vacuum all at the same time? It would be very challenging. You can really only do one thing well in one moment at a time. And so the functions allow us to focus our attention to break down our problem into manageable bite-sized chunks that are easier for us to work with. And that's how it helps us test and debug faster. Functions also help us reuse our code, which is one of the main reasons we write code and programs in the first place, is so that they can be reused over and over and over again. And finally, functions help us eliminate repetitive code, which is also a really important component of programming. When we go to reuse our programs, or if we want to edit them later, it means we only have to make changes in one well-defined place. And this is really helpful because if we've been copying and pasting our code all over our program and we have a bug in one of those, or we probably have a bug in all of them. And so we'd have to go back through and remember to make changes in all of those different locations. By putting that repeated code in a function instead of copying and pasting, then it's going to simplify our development. It's going to simplify our lives for creating working pieces of code. All right, so now let's look at an example function. We're going to start with a really simple function called add. And what's going to come into this function are going to be two parameters, x and y. These are the values that we're going to pass into the function. And then what's going to come out of our function is the result, or the sum of x and y. More formally, the parameters coming in are x and y, and what comes out is called the returned result. In this case, it's going to be our sum. So let's take a look at what our Python code might look like to call such a function. So here's an example line of code that calls the add function that we've been describing. It starts with the function name here on the right-hand side of the equal sign. And then in parentheses after the function name are our parameters. In this case, in the call of the function, these are the actual values that we are going to pass our function. It's not x and y, it's 5 and 7, the actual numbers that we want to add together. Then once the function is executed, the result gets stored in our sum variable, and this is the returned result. And the equal sign is what's doing that assignment for us. So now let's look at how we might define such a function. And again, this is in Python. So here we have a simple function definition for the add function. And let's talk about each component in turn. First, we start off with the Python keyword def. This tells Python that we want to define a function. And this first line is known as the function header or signature. Then we have the function's name, add, followed by parentheses, and we have x and y. These are the parameter variable names. So these are variables we're creating, and these variables only exist in this one function. That's what's called their scope. After that, every line of our function is going to be indented. Python is really persnickety about indentation. This particular function is very simple, and so I just have one line, but if we had multiple lines, all of those lines would need to be indented as well. Return is the keyword that we use in most programming languages to give a result from a function and to exit that function. And it's going to immediately exit that function. And then the value that we're going to return comes after that keyword, and that's our result of adding x plus y together, which is what our add function is intended to do. Now let's put our call and our function together to see how a program works. Now in this program, I'm also going to represent what's happening in memory, or RAM, while our program is running, and that's indicated in the green box. So I'd like you to take a moment and think for yourself, where does our execution begin? What do you think is the first line of code that's going to be executed? If you said the add line where sum equals add 5, 7, then you are correct. While the function definition happens earlier in the program, from a user's perspective, you could put 100 function definitions in your program, but if you never call them, it's like they don't exist. So our execution from the user's perspective actually begins below all the function definitions, where the functions are actually called. So let's look at how our execution flows through the program. So when the add function is called, the actual values of 5 and 7 get copied into our parameter variables x and y. And this is happening behind the scene, which is why function calling can be a little bit challenging for new programmers, because all of a sudden you're not flowing through your function one line after another. Things are bouncing around and happening behind the scenes. You need to understand what's called the semantics of what's happening there. So we've copied the values of 5 and 7 into x and y, and we can also see they're represented in memory in our diagram. Then we're going to execute the two statements that are in the function's body, both of which are indented. And then when the add function is finished, it returns the sum and assigns it to our sum variable. Okay, and then finally, we're going to print our sum, and that's where the execution ends. So what I'd like to do is summarize all of these different components and the flow that we saw. So first we started with our call to add 5, 7, which was then passed to our function definition. And so those variables, x and y, get the values 5 and 7. We printed, we returned x plus y, and then we assigned that result to our sum. And finally, we then printed it. And what I really want to draw your attention to here is how the flow of execution from statement to statement is nonlinear. It's bouncing around. It's going from here, it's going to there. And so once you start building well-written programs that are making use of loops and functions, things don't just follow in a straight line anymore. And so it's important to understand the mechanics of what's happening behind the scenes so that you can understand what your programs are doing. And finally, what I'd like to leave you with is a question I see all the time from beginner programmers. What's the difference between returning and printing? So let's contrast the add function we've been working with here, which returns the result x plus y, with a version of add that only prints the result. So the function on the right with print will only ever display to the screen. And while that might be what we want to do right now, it might not be what we always want to do with our sum. And so return allows us to give our result back to the location of the call so that we can then assign it to a variable, pass it as a parameter, and use it inside another function, or print it. And so return allows us to use our function in a way that can be used in many more situations than just printing. Thanks so much for watching. If you like this video and would like to see more, please post your questions and topics below, and I'd be happy to answer them in the future. Take care.